Welcome. This is the second triangle on task 5.6. And again, what's given is we've got a side length, another side length, and we've got one angle. We're going to try and find the other two angles as well as the third side length. First thing we can do is use the sine function, sine of 35. And I am going to use it for this right triangle that I've created by dropping an altitude h at point D. And so sine of 35 degrees opposite over hypotenuse here. So it would be h over 13.8. Therefore, h is equal to 13.8 times the sine of 35 degrees. And when I plug that into the calculator, I get h as approximately 7.41. 7.41. That looks reasonable, looking at the diagram. And so I can use my Pythagorean theorem to find BD. So it's 13.8 squared minus 7.41 squared is going to be approximately 11.64. I can also use that height and Pythagorean theorem to find AD, which is this section of this right triangle. It'd be 8 squared minus 7.41 squared. And that's approximately 3.02 units. So now if I add those up, 11.64, 3.02, I get 14.66. So approximately 14.66 units for C. And that seems reasonable looking at the diagram. I can also calculate A using the sine function. So the sine of A is equal to, here's my A, and the sine of A is equal to opposite over the hypotenuse, h over 8, which we said h is approximately 7.41 divided by 8. So now we can take the sine inverse of 7.41 divided by 8, and that will give us the angle, which is approximately 67.9 degrees. And the final piece here would be angle C, using 180 degrees as the angle sum. So 180 minus the 67.9 minus the 35, and let's see, so that gives us 145. 145 minus 67.9, so that would be 145 minus 67.9. And I've confirmed, yes it is, it's equal to 77.1 approximately, so 77.1 degrees.